We will now discuss the second part of how mathematics are incorporated with physics. We had already discussed and covered the fundamental importance of measurements in science, such as units associated with measurements, calculations involving conversion of units, and scientific notation. In today's discussion, we will talk about the limitation of reading errors when making measurements. We will focus on understanding of accuracy and precision, and types of error effects which can affect measurements such as random error and systematic error. Measurements are very important because we can use it as a standard for everyday living and process such as weight, temperature, length, and even time is a measurement, and it does play a very important role in our lives. Besides, even the money that is very essential in our everyday needs involve measurement. In taking scientific measurements, it is very important to understand both accuracy and precision. Accuracy is the closeness of measured value to actual value or true value. It is also refers to the correct value and not repeating. Example, Jerry is obtaining a weight measurement of 47.5 kilogram in clinic. He went to another clinic and measures his weight again and he got a result of 48 kilograms. This example is accurate because 47.5 kilogram is also the same as 48 kilogram if we are going to round it off. Therefore, 47.5 kilogram is close to the actual value of 48 kilograms. Another example is a basketball player achieving to take the ball close or into the basket. In playing basketball, the aim of a basketball player is to bring the ball into the basket. In this case, the player is about to take the ball close or into the basket, which is in relevance to the main goal of the game. Thus, the action of player to the goal of the game is relevant to each other. So, it is accurate. While precision is the closeness of measured value to each other. It is repeating, meaning it's like striking the same spot but maybe not the correct spot. Example, Tom is obtaining a weight measurement of 51 kilograms in clinic, but his actual or known weight is 75 kilogram. This example shows precision because 51 kilograms is so far from the weight of Tom, which is 75 kilogram. Another example, a basketball player taking the ball into the same location but may or may not close to the basket. The goal of basketball again is to shoot the ball in the basket, where in this case, the player is not achieving, even though the player is taking the ball always in the same location. However, it's not in close to basket, so it's just a precision. We can compare accuracy and precision in playing the dart. If you hit the bullseye, it means you show accuracy. On the other hand, no matter how you are trying to hit the board, but you are not hitting the target, your doing is just a precision. If the measurement done several times and all values are close to each other but not to actual value, like targeting the board, not hitting the target, it indicates a bias. A bias is an error that creates all measurement wrong through a certain amount. Therefore, all measurements done by the same amount are wrong because of bias. Example, the weighing scales measures 5 kg when there is none. If you will get your weight using the weighing scale, you will always get wrong measurement because it's already have a weight even there is none in it. Another example is measuring height wearing a shoes or slippers. Wearing shoes or slippers while getting height will lead to added measure, which will be far from the actual value or height. And lastly, a clock which is 10 minutes advance. This will lead to disputable record if somebody is trying to ask you what time is it. Therefore, in making measurement, we cannot assure that we are always getting the exact amount of what we are going to measure. We may encounter errors such as random and systematic error. Random error is an error which is non-predictable and cannot be reproduced by doing the experiment again. This usually happens due to incorrect using of apparatus or due to environmental factors, such as measuring height that is affected by different posture changes. People have different posture. As we get older, the bones on the spinal column, such the vertebral disc, lose height, causing one's height to shrink up to 1/2 inch or even more. Another example is weighing oneself in scales, getting 120 libs, 138 libs, and 150 libs. This is because a person gains muscle mass that may affect his or her weight. Since dense muscle tissue takes up less space than fat, it's possible that someone may weigh the same or even more. Next is systematic error. This error is consistent because it produces consistent errors. If the experiment is done several times, the error that will produce is the same. So why the systematic error is consistent? That is because of the faulty equipment and or flawed experimental design. Meaning, this error usually happens due to the equipment's fault. Example, measuring length using a metal ruler. Getting length using a metal ruler will have an impact in getting the measurement because the metals will shrink when the temperature is hot and it expands whenever the temperature is cold. So because of these changes, it may affect the measurement of an object. A weighing scale that doesn't read zero when nothing is on it. In this case, the object's mass will not be accurate because of the added value, since it's not set to zero. There are two types of systematic error. The first one is the offset error. This usually happens because the instrument is not set to zero when in use. Just like our example earlier, the unset weighing scale. And lastly, the scale factor error. This one is correlated to actual measurement, such as using a metal ruler as a measurement tool. However, even we can encounter these errors in measurement, we can avoid or minimize them by means of reading measures repeatedly and improving the design of the apparatus.